All right, 4.4, exponential and logarithmic equations, day 2. So we're going to use the one-to-one property of logarithms to solve log equations, and we're going to solve applied problems involving exponential and logarithmic equations. So to use the one-to-one property of logarithms to solve logarithmic equations. So it says we're going to express the equation in the form of log base b of m equals log base b of n. This form involves a single logarithm whose coefficient is 1 on each side of the equation. Then we use that one-to-one property that we've done before, so we will actually ignore the log base, oops, sorry, that's in yellow. Try this one. So we'll ignore those log base m's, and then remember that means that m has to equal n. So whatever we're taking the logs of will be equal. You're going to solve for the variable, but again, because our original equation has logs in it, you have to check your answer, okay? You have to plug it back into here and here to make sure that the number that it gives you is going to be a number greater than 0. All right, so here in this example, we have the natural log of x minus 3 is equal to the natural log of 7x minus 23 minus the natural log of x plus 1. So I notice they all have log of the same base, but on the right side here, I have two logarithms. So I can actually go ahead and put those together because they're being subtracted. Remember, that means we can combine them by division. So I've got the natural log of 7x minus 23 over the x plus 1, and that's just equal to the other side here. And then we have a log is equal to a log. They have the same base, so we're going to ignore them, our log bases. And so we know that the x minus 3 has to equal 7x minus 23 over x plus 1. Now, we don't have any x's in exponents, so this is just back to our getting rid of fractions like we've been doing since the beginning of the year. So we're going to multiply by the denominator to both sides of the equation. So on the left side here, I'm just going to write it out. I have x plus 1 times x minus 3 equals, and on the right side, my x plus 1's cancel, so I just have 7x minus 23. So I'm going to multiply those two on the left there. So I'm going to come over here in this top right corner. I'm going to make myself a box. When we're multiplying, we put this stuff on the outside. So I have x plus 1 times x minus 3. Remember, we multiply x times x and get x squared. Going across, I have x times 1, which is x. Bottom left, negative 3 times x is negative 3x. And then negative 3 times 1 is negative 3. I'm going to combine my like terms, write it in descending order. So x squared, x minus 3x is negative 2x, and then I just have my minus 3. So on the left side here, we have x squared minus 2x minus 3 equals, and on the right side, we still have 7x minus 23. Now remember, anytime you have x squared and x in an equation here, you're going to need to factor, so we need to set this equal to 0. So I'm going to move this side over by subtracting that 7x, and I'm going to add the 23. So when I do that, I get x squared minus 9x plus 20 equals 0. And now we're going to have to factor. So I'm going to go and I'm going to build me another box, and let's see, let's do this in light blue. So I'm going to make me another box here, and I'm going to make the t-table. So remember, inside my box, I put my x squared, and I put my constant. And then for those middle two, those other two boxes, I'm going to use my table to help me. So I know the first column is a times c, so 1 times 20. So they're going to multiply to positive 20. And they have to combine to b, which is a negative 9. So we have 4 and 5 that multiply to 20, but they have to be negative to give me negative 9. So I have a negative 4x and a negative 5x. And then we greatest common factor each row and each column. So I'm going to take an x out of the first row, a negative 5 out of the second row, an x out of the first column, and a negative 4 out of the second column. So I have x minus 4 across the top, and I have x minus 5 down the side. And so remember, this is equal to 0. then set them each equal to 0 and solve. So x minus 4 equals 0, x minus 5 equals 0, and solve for x. So we get x equals 5, and we get x equals 4. But we're not done yet, because remember we had log in the original problem, so we have to check our answers. All right, so I'm actually going to erase what I wrote here so that I have some room to show checking my answer, because I'm just going to use the original problem. So we said our answer, one of our answers was 4. And so when I check that, I'm going to plug 4 into each of these 3 things here, what I'm taking the logs of, okay? So the first one is x minus 3. So 4 minus 3 is 1. Remember, we need it to be positive, so it's good there. Then I have 7x minus 23. Well, 7 times 4 minus 23. 7 times 4 is 28 minus 23, which is 5. Again, that's positive, so that's good. And the last one there is x plus 1. So I'm going to plug that 4 in. So 4 plus 1 is 5. And that's positive, so that's good. So 4 is definitely an answer. I'm going to box it down here. And then I'm going to check when x is 5. Same thing, so plug it in that first one. The first one was x minus 3. So 5 minus 3 is 2. That's positive. Then we had 7x minus 23. So 7 times 5 minus 23. 35 minus 23, which is 12, which is positive, so that's good. And then our last one with x plus 1. So 5 plus 1, which is 6. That one's positive. It's also good. So these are both my solutions. So 4 and 5 are both solutions that work. All right, and then an application problem here. It says, how long to the nearest tenth of a year will it take $1,000 to grow to $3,600 at 8% annual interest compounded quarterly? So this goes back to what we did in one of the previous lessons when we talked about compounding. And so remember we said there was compounded with a number, or there's compounded continuously. If it said compounded continuously, we would use that PERT formula, the A equals PE raised to the RT. If it didn't say compounded continuously, we used the other formula, which is A equals P parenthesis 1 plus R over N raised to the NT. And so in this one, because it says compounded quarterly, that means we're using that second formula. So I'm just going to list my variables here, and let's see what we can fill in. So 1's a number, we have R, N, and T. So it tells us how long, so we know we're after time, to the nearest tenth of a year will it take $1,000 to grow. So we're going to start with $1,000, and we want it to grow to $3,600. So that's my ending amount. At 8% annual interest, so 8% is my R, but remember you got to change that to a decimal, so divide it by 100, so 0.08. Compounded quarterly. Quarterly means 4 times a year, so my N is going to be 4. So we're going to plug this into that equation. So I'm just going to write out my equation again. So we have 3,600 equals 1,000 times 1 plus our R over N raised to the N T. And we don't know T, so leave it as T. All right, so the first thing I'm going to do is I got this 1,000 times. And so I'm going to divide by it to get rid of that 1,000 there. What you do to one side, do to the other side. So I'm going to get 3.6 equals, and I'm going to go ahead and I'm going to plug this into my calculator. It's inside parentheses, so I'm going to plug it in and see what I get. And so I type that in. I got 1.02 raised to the 4t. Now you don't have to write it in parentheses. I just did because it was in parentheses. But now our problem is that we have our t, our unknown, our variable, is up in the exponent. And so we've been learning that the only way to get a variable out of the exponent is in order to use that power rule. In order to use the power rule, we have to have a logarithm. So let's log both sides. And again, like what we did in part 1, it doesn't matter, or day 1, excuse me, it doesn't matter if we use log or natural log. We could use either one. All right, now that we got a log, we can take that exponent and move the whole thing in front of its log. So we have log of 3.6 equals 4t log of 1.02. Now I want to solve for t, which means I need to get rid of the 4 and the log of 1.02. These are all being multiplied, so I'm going to divide by both of them at the same time. So I'm going to divide by 4 log of 1.02. So my 4's a cancel, my log's a cancel. So divide this side by 4 log of 1.02. And so we'll get, I'm going to write it here. So you have log of 3.6 divided by 4 log of 1.02 equals, and we just have t over there. So if it asks for the exact answer, that would be our answer. But now let's go ahead and let's plug that in our calculator and let's see what we get rounded to the nearest tenth, because that's what it says in the directions. So in your calculator, I'm going to hit that alpha x to make it a fraction. I'm going to do log of 3.6, close my parenthesis, divided by 4 log of 1.02, close my parenthesis, enter. And so I got 16.171, blah, blah, blah. Nearest tenth, remember 10 has 1 0, so it means one place. So we got to look at the 7. Is that going to make the 1 stay the same or make it round up? Remember, 5 or more raise the score, so it's going to go up. So 16.2 years. All right, and another application here, it says a percentage of adult height attained by a girl who is X years old can be modeled by f of x equals 62 plus 35 log of x minus 4, where x represents the girl's age from 5 to 15, and f of x represents a percentage of her adult height. At what age has a girl attained 97% of her adult height? All right, so again, they gave us an equation. Let's pull it out. So f of x equals 62 plus 35 log of x minus 4. Remember, make sure you know what your variables represent. So we have f of x. That is, before the equation, it says the percentage of the adult height attained by a girl, blah, 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 can be modeled by. So this is our percentage of adult height. Let's do a percentage of height. And then what is x? X represents the girl's age right there. So it says, at what age has a girl attained 97% of her adult life? So this is going to be point, hold on, let me see. Nope, it says it's the percentage. So 97 is going to be my f of x. So 97 equals 62 plus 35 log of x minus 4. Right now that x is inside that logarithm, so let's get log by itself. So first let's move the 62 over. So 97 minus 62 is 35 equals 35 log of x minus 4. Well, that's 35 times log, so we want to divide by that 35. So 35 divided by 35 is 1 equals log of x minus 4. And so I'm just going to rewrite this over here. So it's 1 equals log of x minus 4. Now I'm in log form, but I can't do anything else. There's not 2 logs, so I can't use that 1-to-1 that we did at the beginning of the lesson today. So remember, if you get stuck in log form, go to exponential form. So I know my b is 10 because it's not written. My x is my x minus 4. And my y is 1. So when I change it to exponential form, I have b to the y equals x. Work out your 10 to the first. And then solve for x. And so we find 14 equals x. And so let's see. We did have a log at the beginning, so I need to check that. If I plug in 14 in there, is that okay? Well, 14 minus 4 is 10. I can take the log of 10 because 10 is positive. All right, so my x is equal to 14 years old. All right, and that is the end of 4.4.